The other method that we can use to solve linear equation, to solve a system algebraic, is what we call elimination. So elimination is going to work when we can't substitute. And generally speaking, when we eliminate, what we want to see is we want to see one of the two variables have opposite signs and they have a matching coefficient. The coefficient is the number in front of the variable. So we want to see something where either the x's have opposite signs or they have matching coefficients. If they don't have that, that's okay. We can make them be that by multiplying, because we can multiply by both equations by any number we want to make them be the same. So when I look at these first sets right here, I want to try to eliminate either the x or the y's. I'm going to eliminate x. I want to make these be the same coefficient. So in order to do that, I'm going to multiply the first equation, the top equation, by 4. I'm going to multiply everything by 4. I'm going to multiply the bottom equation by a -3. And here's why I'm multiplying by -3. I want to multiply the top equation by 4 to make it into a 12. I want to multiply the bottom equation by 3 to make this a 12. But I want them to be opposites. So I multiply this one by a -3 to make it a -12. I'm going to multiply everything in that equation by 4. So I'm going to get 12x plus 20y is equal to 16. And then -12x minus 9y equals a positive 6. And again, I did that. By doing that, it made these have matching opposite coefficients. And so now I'm going to add these equations up. And when I add, these are going to eliminate or cancel. 20 minus 9 is 11y. 16 plus 6 is 22. Isolate that 11y, get that y by itself, divide both sides by 11. I get y equal to 2. Once I know the value of y is 2, I can take any equation that I've created, these multiples or these originals, and plug in for y to solve for x. I'm going to focus on this top equation up here to do that. So that's 3x plus 5 times my y, which is 2 now. That has to equal 4. So that's 3x, 5 times 2 is 10. That equals 4. Isolate x. So I'm going to subtract off 10 on both sides. And I get 3x is equal to a -6. Divide by 3. Divide by 6. Divide by 3. X equals a -2. So the solution set here to satisfy both equations, what we call that is -2. I mean, it's positive, -2, which is the x value, +2, which is the y value. So let's look at this one. Again, I want a matching coefficient to be opposite signs. Well, here I can either go after the 8 and the 3, or I can go after y and y. These have opposite signs, but they need to be matching. So I'd have to multiply the bottom equation by 8, the top one by 3. Easier thing to do is multiply one of these equations down here by a negative, either this one or this one. And I'll multiply the bottom equation by a -1. Because I want to flip the sign of y here. So the top equation is going to be 8x plus y equals -16. Didn't touch it. The bottom equation, all the signs flip. So that's 3x minus y equals a +5. I'm going to add these equations up again. 8x plus 3x is 11x. These are going to cancel or eliminate. And then -16 plus 5 is a -11. Solve for x, divide both sides by 11. I get x equals -1. Again, I can go to any equation I want to and solve for the value of y. I'm going to just take the top equation again. So I'm going to say 8 times x, which is -1, plus y equals -16. So that's -8 plus y equals -16. I'm going to add 8 to both sides. When I add 8 to both sides, I get y is equal to -16 plus 8, a -8. So my solution set, my x value is -1, my y value is -8.